Hey guys, it's Layla. Today we'll speak about the reactions of alcohols mainly and a little bit about aldehydes and ketones. So alcohols, once again, a review. We have three types. You have primary, secondary, and tertiary. So primary is when it is attached to one carbon. Secondary is when it is attached to a carbon between two other carbons, and tertiary is when it is attached to a carbon between three other carbons. Alright, so primary alcohols are more acidic than secondary, which is more acidic than tertiary. So, and if you have more hydroxyl groups, the acidity will increase. I've mentioned earlier that primary alcohols get oxidized to aldehydes, secondary to ketones, and tertiary do not undergo oxidation. So alcohols are very weak acids. They're weaker than water, which is less acidic than cyclic alcohols like cyclohexanol, which is also weak because it is less acidic than carbonic acid, which is a weak acid. Okay, showing the oxidation of methanol, a primary alcohol, to aldehyde is using oxidizing agents like potassium permanganate, or even in an acidic environment, you will get an aldehyde. So from methanol, you will go to methanol and you release water. With secondary alcohol, you will go from 2-propanol to propanone and water. Alright, so primary alcohols can be further oxidized to carboxylic acid. So you go from primary alcohols to aldehydes and to carboxylic acids. Taking the example that we just did, so formaldehyde or methanol upon further oxidation will become methanoic acid or formic acid. You will just add another hydrogen due to oxidation. Another reaction of alcohols is esterification, which I've already spoken about in another video. So esterification is when alcohols react with carboxylic acids, releasing water and forming esters. So moving on to the third type of reactions, it is the reactions of alcohols with metals and metal hydroxides. So the first one with metals taking sodium, and the second one with metal hydroxides taking sodium hydroxide. So the reaction, if you remember from carboxylic acids, it is the same. The hydroxyl group reacts in the same manner. So you will just remove the hydrogen and substitute it with the metal. For example, taking methanol plus sodium, we're going to get CH3O minus and Na plus, like a salt. And we're going to release hydrogen. With metal hydroxides, the difference is that the first product is the same, but you will release water instead of simply hydrogen. The fourth type of reaction is dehydration of alcohol. So there are two types, or two ways in which they can be dehydrated. In the presence of concentrated sulfuric acid and high temperatures, alcohols can be dehydrated into either ethers or alkenes. So ethers are alkyl groups bonded with an oxygen atom, and alkene is double bond between two carbons. Alright, so the first type is methanol. You need two of the same alcohol. So you take two molecules of methanol to get a dimethyl ether. So methyl on both sides bonded by an ether bond or oxygen. The second type is the alcohol. You cannot have methanol because an alkene needs two carbons. So taking ethanol, you will get an alkene, which is ethene, and a water molecule. Phenols are an exception because they cannot be dehydrated. Okay, the last type of reaction of alcohols is the formation of acetal or ketals. So this is the reaction between an alcohol and an aldehyde for acetal, and an alcohol and a ketone for ketal. So you need two molecules of the alcohol for the final product, but for the intermediate you can take only one molecule. So put the central carbon first put the groups that it's got in the original aldehyde, so you have R and H, you have to break the double bond with the oxygen, and then you will get two single bonds. One is with a hydroxyl group and one is an ether bond with the alkyl group of the alcohol, that is hemiacetal. When you have acetal, the hydroxyl group also mimics the other bond and you get two ethers. The same is with ketones. So you take the central carbon, put the R and R1 alkyl groups. So you have the double bond O, you break it, you get two single bonds, one hydroxyl group, one with an ether, and then all four bonds become two alkyls and two ether bonds. So you have hemiketal and then ketal. One last thing I'd like to say in this video is about the reduction of aldehydes and ketones to their alcohols. So primary alcohols, if they can be oxidated to aldehydes, aldehydes can also be reduced to primary alcohols. So it's a reversible reaction under like catalysts like nickel and high heat and pressure. Secondary go to ketones, and then ketones can also be reduced to secondary. So aldehydes and ketones, they undergo nucleophilic addition reactions. Now we'll move on to the homework for today. So question number 1, show the final oxidation of propanol. Question number 2, show tautomerism. I will show you a ketone and you have to show me tautomerism, which we did in one of our inorganic videos. Question number 3 is show the reaction between methanol and acetaldehyde. And the last question is show the dehydration of propanol. And that is it for this video. I will see you in my next one. Bye.